two lines or rays or segments intersect somewhere, they will make an angle. There's a certain angle between those. We're specifically going to talk about angles with rays in this lesson. So an angle consists of two different rays with the same endpoint. Okay, so over here we have point A, this is the endpoint, and then the rays go from A to B, and from A to C, and then between those rays is some angle. All right, so the sides of the angle are the rays themselves. The point at the end, the endpoint that makes the angle, or the point where the angle is, we call that the vertex. So that's the endpoints of the rays. When we're naming an angle, the notation that we use is, well, first of all, just like with a line, we drew a line. With a segment, we drew a segment. With an angle, we're going to draw an angle. And so if we're wanting to, say, name this angle that goes from W to X to Y, we need to list all three of those points. We need to list a point on the starting ray, then the vertex in the middle, and then a point on the other ray. So this angle, if we say angle YW, let me try that again, angle WXY, that's starting at W, going to X, and then going over to Y. So the vertex of the angle, the point where the angle actually is, that goes in the middle, and then a point on each ray goes on either side, W and Y. So we need 3 points. So if I just say, like if I were to say something like angle X, that is completely ambiguous. So angle X could mean that angle that's in red, it could mean this angle that's in green, it could mean this angle that's in blue, it could mean any of those. So if I just say angle X, it is completely ambiguous. So we need to have 3 points for any angle that we name because we need that specificity. Now there are occasions where it is acceptable to just list 1 point. Like for example, up here, I could call this angle A, and that's because there's no other angles at point A. So if I just say angle A, there's no confusion about what angle I'm talking about. And you will see that in your book occasionally. But when you're naming angles in this class, I want you to always use 3 points. So I will never accept you just naming an angle with 1 point. I want you to always use three different points just to keep it as specific as possible. So there's no ambiguity in what you're talking about. All right, so we could name one of the angles. We could name it WXY. Another angle we could name would be the one in green there. So that one I would say angle YXZ. And then the one in blue, if I wanted that one, I could say angle W. There we go. Pen wasn't working there for a minute. Okay, ignore that. I could call it angle WXZ. So these 3 things here, these are 3 names for 3 different angles on that. Now I should mention you can list these the other way around. So it would be perfectly acceptable to call this one angle YXW and so on. As long as the vertex is in the middle, that's the important thing. All right, there are 4 basic kinds of angles that we're going to be looking at. They are classified as acute, right, obtuse, and straight. So an acute angle is something that's less than 90 degrees. So the first example here is an acute angle. So it's going to be greater than 0 degrees, but it's going to be less than 90 degrees. And what this should say in the middle, actually, it should have the angle symbol there. So if you have the M in front of angle A, that's talking about the measure of angle A. That's how many degrees the angle is. So just like with the segments, we kind of had 2 different ways of talking about it. One talking about the object itself, and then one talking about the length. So if you remember, if we have something like, say, BC, that's the length, the distance between B and C. Whereas if we have something like that, that's talking about the object itself, the segment. We have something very similar with angles. So if I say angle A like that, that's talking about the object, the angle itself. But if I have M with an angle A, that means the measure of angle A. That's talking about how many degrees the angle is. Okay, so if we're talking about the measure of angle A here, that's got to be between 0 and 90 if it's going to be an acute angle. For the second one, again, that should have the angle symbol there. The measure of angle A, if it's going to be a right angle, that's 90 degrees. So we have a special name for, should have a degree symbol here. We have a special name for a 90-degree angle, call it a right angle. All right, obtuse angles, those are going to be somewhere between bigger than 90 and less than 180 degrees. By the way, if you don't know this little circle I'm putting above the numbers, that means degrees. So it's talking about it's the measure that we use for an angle. And then the last one we have is called a straight angle, which is just a straight line. But this is 180 degrees. So it may not seem like that should be considered an angle because it's just a line, but we do consider that to be an angle. So we do have a vertex A right here, and we have a ray going this way and a ray going this way. They are opposite rays, but the angle that's made between them, if you think about going from this ray over to this ray, you go 180 degrees to get around to that. So it is an angle. All right, when we're measuring angles, we use a tool called a protractor, which is that thing that's been sitting off to the right there this whole lesson. Let me pull that over, and we'll start measuring some angles. So what you want to do is you want to put the protractor on your set of angles. So the important bit, actually let me pull to the side here. So you want these crosshairs right here. So from here and then here. So where those meet, that should go on the vertex of your angle. So it gives you those crosshairs to put it on the vertex of the angle. So a very common mistake that I see with students is that say that their angle looks something like that. They put the protractor right there at the bottom. So the bottom of the protractor is on the bottom of the angle. This will give you an incorrect angle measure. So it's very, very important that you get these crosshairs here. You put those on the vertex of the angle, just like that. My page flipped. There we go. All right, so let me bring it back over here. So we're going to put those crosshairs on the vertex of the angle. And then you just have to measure going either from the bottom of the right side or the bottom of the left side, depending on which way the angle opens up. So if we're looking for angle KHJ, that's the first one. So KHJ, that's going to go, let's see, KHJ, I can't see with the projector there, or protractor there. So KHJ is this one right here. So take the protractor, put the crosshairs on the vertex, and then you can see up here on the right side, the angle opens up this way, and so we're going to start from 0 on the right side and count up. So this one's just over 50 degrees. Call it maybe 52. So this is a 52-degree angle. All right, if we want to measure angle GHJ, so that starts here, GHJ, so with the vertex in the middle there. Well, that one we don't really need a protractor for. That's a straight angle. That's going to be 180 degrees. All right, GHK. Let's do that one next. So starting at G, going over to H, and then up to K. So this angle is opening up this way, which means we're going to have to start at 0 degrees down here and then count up as we go to opening up the angle. So put the crosshairs on the vertex. Start from 0 over here and count up going this way till we get over here. Oops. And that's looks like just under 130 degrees. Maybe call it 128. And then the last one is GHL. So starting at G, going over to H, and then up to L. Now again, we could use the protractor, but that one is pretty clearly going to be a right angle. So we could say that's 90 degrees. We could measure that on the protractor too. Put the crosshairs on the vertex there, and you see that that ray points straight up to 90. Now we're going to look at something called the angle addition postulate. So this is very similar to the segment addition postulate, which if you remember that, we have a segment, say this is A, B, and C. So if we look at the segment length between A and B, and then we look at the segment length between B and C, if we add those two lengths together, then we're going to get the length from A to C. Fairly straightforward. So let me give you some numbers as an example. So say that this one is 4 and this one is 2. If we want to know the length of the whole thing, we would add those together and get 6. We can do the exact same thing with angles. So if we're looking at this angle right here and this angle right here, and if we have angle measures for both of those, we could find the angle measure of the red one there just by adding the two angles together. All right, so if we're looking for the measure of angle, RST, and it should have that angle symbol there, measure of angle RST, we can take the measure of angle RSP, that's this one in red, and we can add to it the measure of angle PST, which is this one in green. If we add those two angles together, we'll get the measure of the entire thing. All right, let's use that in example 3. So it says the measure of angle, LKN. So that's the measure of the angle going all the way around like this. That is 145 degrees. And it's asking us to find the measure of angle, LKM, and the measure of angle, MKN. So what we're going to do is say, okay, let's take this angle and then add to it this angle. So there's two smaller pieces there. If we add those two together, we should get 145. Well, we have expressions for those two angles. We don't actually have numbers for them, but we can add the expressions together just the same. So if we take the expression 2x plus 10, which is the angle of the one on the left, add to it the angle of the one on the right, which is 4x minus 3, we have to get 145. Now we've got an equation, and we can solve this. So let's combine like terms. We've got a 2x and a 4x together will make 6x. We've got a 10 and a negative 3 together will make positive 7. And then we're going to, let's see, we got to subtract that 7 over to get just the 6x by itself. So we'll subtract 7, we get 138 on the right side, and 6x on the left side. Divide both sides by 6 to get x, and we get x equals 23. Remember, that wasn't the answer though. So what we were asked for is the measures of these two smaller angles in here. So we're looking for the measure of LKM in green, and then the measure of MKN in blue. So to get those measures, we're going to have to take 23 for x, plug it back into these expressions. So in the one on the left, we can take 2 times 23 plus 10. So 2 times 23 is 46, plus 10 gives 56. So LKM, this one here, is a 56 degree angle. Now we could take x equals 23 and plug it in here for x to get the other angle, the blue angle. But there's another way that we could do this. So now that we know that this green angle is 56, and we know that the entire thing has to be 145, well, we could just take the 145, the red angle here, and subtract off that green part. So if we do 145 minus what we just found was 56, that gives us 89. So that tells us that this one right here is 89 degrees. And if you want to check that, you're welcome to plug x into 4x minus 3. Plug 23 into 4x minus 3, and you'll see you get the same thing. All right, so remember that the word congruent is the geometry version of equals. So instead of saying that two shapes are equal to each other, we say they're congruent to each other. And that just means that they're fundamentally the same thing. So two angles are going to be congruent if they have the same measure. So the same number of degrees. So just like if two segments have the same length, then they're congruent. If two angles have the same measure, then they are congruent as well. All right, so again, we use equals for numbers, congruent for shapes, objects. So this equation here, we could have the measure of angle A is equal to the measure of angle B. Whereas if we're talking about the angles themselves, the objects, we're going to say that they're congruent to each other. So again, we use equals for the measure because that's a number. You know, we might have a 36-degree angle. That's a number. So we say the measures are equal. Whereas if we're talking about the angles, the objects themselves, we say they're congruent. All right, and if we're talking about congruent angles, just like how when we had segments, if we say that this segment is congruent to this segment, we can put a dash on them to indicate that they're congruent. We can do the same thing with angles. So in example 4, these two angles here that have one kind of arc in them, those are congruent to each other. And then these two angles here that have two arcs going through the angles, those are going to be congruent to each other as well. All right, also thinking back to segments, we have bisectors. So a bisector, remember, is a segment that cuts, or anything that cuts something exactly in half. So we can have angle bisectors too. So an angle bisector is a ray that cuts an angle exactly in half. Now it's got to be a ray because we can't have a point cut an angle in half. That just doesn't make sense. But we can have a ray cut an angle in half. So a ray that divides an angle into two angles an angle bisector is a ray that divides two angles, divides an angle into two angles that are congruent. All right, let's look at example 5. So we have ray YW, that's the one in the middle. So that one highlighted in green here, this is the bisector of the angle, which means it cuts the angle exactly in half. So if the measure of angle XYW, that's going to be the top one, is 18 degrees. It says find the measure of angle XYZ. Well, XYZ is the outside here in red. And again, if it's a bisector, it cuts it exactly in half. So that means if the top is 18, the bottom has got to be 18 too. They must be equal if it is a bisector because it gets cut exactly in half. So then all we need to do is just take 18 plus 18. So we get 36 degrees. That is the measure of angle XYZ.